Okay, thank you very much, everybody, and thank you, PTAC, for providing the opportunity. I hope you can see my screen now.
Yes.
And before starting, I want to take the opportunity to thank everybody as a guy with 25 years experience with the mining that have a privilege to come and talk about in the oil and gas group. My terminology might be a little bit different because of my background. Please forgive me for any use of the terminology is not the same as the oil and gas. I try to be quick, and if I get a chance, I try to show you some small animation at the end to explain the technology. However, there's an existing liability in the mining industry that we know as a low pH tailing pond water that require the pH adjustment before discharging, and normally they have high concentration of the heavy metal due to low pH that they have. In some cases, this pond or tailing pond is the only available source of the water or the most accessible one. And treating these is a kind of the financial burden for all mining industry and oil and gas industry. Currently, there are three different approaches for treating the water. One of them is the pond neutralization, which means injecting the neutralizing reagent directly to the pond or to the inflow. The second one, which is the most common one, is the active treatment of the pond outflow, which redirecting the outflow to a treatment facility and the discharge and the treatment and discharge the water. And the third one is the passive treatment, with distributing the pond water to passive treatment facilities such as wetland and let the happen passively and basically discharge the water. Since the active treatment is the most common one, I try to bring a few facts about the challenges that we have the active treatment. One of them is the design malfunction that happened due to non-representative sample, or which caused basically the schedule creep, consumable creep, and budget creep. The second one is the unreliable water volume estimate that normally we have in the industry about how much water we have to treat. Lack of adaptability of the system with the water quality fluctuation, and also reagent overdose and overshoot are a very common problem in the active treatment process. We ignore in many cases the natural parameters such as snow, rainfall, and evaporation on the quality of the water, and then again the treatment goes out of the schedule or miscalculation for the precipitation volume. Since the reagent that we are using in this kind of the treatment are hazardous, normally we have a lot of on-site handling issue, risk, and operational procedure. And also we abolish the potential for the selective precipitation of the metal in this method. In PMAP, basically, we define the technology based on the use of the unmanned smart dispensing vessel for an in-situ tailing pond treatment by distributing of a green, non-hazardous, slow-release reagent into the tailing pond. Our technology had two main pillars. One of them is the slow-release, non-hazardous neutralization reagent formula that we are using. And the second one is the AI-based dispenser, which measures the water quality and quantity online for the precise injection of the required neutralization reagent. There are two basically short animation about that, yet if we have time, I will show you those animation at the end of my presentation. The technology by itself has 4 steps. The first step is the creating the digital map of the pond and basically store all the quality and quantity information of the pond in a kind of the smart system to be able to make a custom plan as a second step for the treating that particular pond. And based on the analysis of the information, we come up with this required slurry property, and we prepared that property, that slurry basically in the third step. And at the very end, we inject the slurry using the AI system at each point based on our calculation and the required amount of the material that we find out from our analysis. Since we are basically eliminating a lot of operation and equipment in our system, we can reduce the capital cost of the operating of the mine water by 85% due to eliminating the mix tank for mixing the material, prevent the movement of the large volume of the water and pumping. Clarification happened inside the pond, so we don't need any clarifier. And also we don't need any equipment for the sludge handling. So basically we can reduce the capex significantly by using PMAP instead of the active treatment. The process that we are using had a few benefits, or I said a few benefits, but I don't know can evaluate a few or not. Basically, we can eliminate the hazardous reagents in the system and all related safety issue. We significantly reduce the number of the required labor because we are using the AI system for distribution. We prevent transportation of the large volume of the contaminated water from the pond to the secondary place, which is the treatment facility. And also we reduce the spill of the contaminated water from the pond since we treat all the water inside the pond. And if the spill happen, basically won't be any contamination associated with the water. In addition, we have some positive impact on the GHG emission. We significantly reduce the consumption of the fuel in the water treatment, so that basically cut a significant amount of the GHG emission. We reduce the equipment fabrication and installation because basically we don't need that much of the equipment, and also we reduce the carbon footprint of the reagent. Plus, of all of these, we have the capital cost and operating cost reduction, as well as we can create the opportunity for recovering the valuable material if there's any in the water. As a summary, I can tell you that basically that our system in comparison with the other treatment have several advantages. For example, our system is way more efficient. We have a smaller volume of the sludge. CapEx and OpEx are considerably lower than the other alternative. We don't need any post-treatment activity, so basically we can save money on that portion. Sludge handling cost is very low because the material precipitated in the pond and we don't need to do any immediate action. Transportation risk and operational risk is significantly lower than the other method because our material are non-hazardous. Environmental risk is very low because we treat the water inside the pond and nothing can spill or nothing bad can happen with the treated water. And also GHG emission, as I mentioned, is very lower in this particular treatment. Just to give a flavor of what we can do, in some of the cases that we have something around 3,870 milligram of the nickel in the water, we drop it to 165 milligram per liter, which means it's something around 95% removal for the nickel. For the copper, we drop from 1,810 to 1.9, which is 99.9% removal of the copper. And for the iron, from 110 to undetectable, which is 99.55% removal. And all of this happen when we are not producing any gypsum and we don't have any scaling issue, which is very common problem in the active treatment using lime. Actually, we redissolve some of the sulfate to the water, and we prevent any potential problem that might caused by scaling. And all of this happened in the pH range between 6.5 and 9, which is the dischargeable pH, regardless of the water quality or pH at the beginning. For example, in this test, we have the pH of the water around 1.9, and the final treated water have the pH around 7.12. So just to make a summary of our technology, I can say we reduced the capital cost of the process by eliminating a significant number of their equipment. And the cost of the operating cost going to be reduced by eliminating the skilled worker and replace them with the AI. And also the sludge volume going to be basically lower, and the cost of the sludge handling going to be very low in this case. In addition, we eliminate the risk of the transportation and operation since our reagents are non-hazardous and green, and we don't have any issue with the spilling the material or overshooting material or things like this. And also we are not dealing with the unknown water quality since we are using the AI and we can do the measurement at the exact point, every point for the injection. We prevent the pH overshoot because our material had the buffering property. We prevent the gypsum formation as we discussed, and contamination, remobilization from the sludge to the water. Also, we create a lot of opportunities such as the green sustainable operation here. We can provide metal recovery option, and also we do the real-time operation control here. Just to give an overview about our current situation, we are geared for the first full-scale operation in a mine in the Yukon. We received 50% fund from the government for our work. The project that we're going to execute have something around 70,000 cubic meter of the water with the manganese, cadmium, arsenic as a main contaminant. The pH of the water is 7.78 that converted to 8.6 at the end of the treatment. We're going to remove 90% of the manganese, 95% cadmium, 60% of the arsenic by adding only 0.1 kilogram of our reagent per cubic meter. The entire operation is going to be in 1 week or 10 days for us. So just about our smart dispensing system or USDV, we design it, we build it, and we commission the system. So we are ready to go for the operation now. For the next step, we are continually working on the R&D for changing our chemical formula for different application. We extend the SUV application for the other treatment technology, oil collection and absorption and other things in the pond. We're adding the required probe and analysis for USDV to do the different analysis, and we are adding robotic arm for the sampling. We have the capability to conduct the bench scale process development test in our lab, prove the concept. We can complete the pilot plant study to gain the client confidence before going to a full scale operation. We can do full scale operation. We can define more pilot project and prove the technology and capability in different industry. And also we can design and build different version of the USDV as a smart dispenser based on the industrial need. And last but not least, I want to let you about what we are looking for. We are looking for collaboration with the stakeholder to aim the industrial pain point. We want to define the more full-scale and pilot project to prove the technology capability in different fields. And we want to support our USDV modification based on the oil and gas industry. So at this point, I'm done with the presentation. And if you want, I can basically switch to some short, basically presentation about our four sub things. I hope you can see my screen.
Yep.
And hopefully you can hear it too.
Through bathymetry, vital hydrographic and water quality data are collected to create a detailed digital map of the pond. This map is used to determine the quantity and quality of the required reagent and injection points. A small volume of the pond water will be pumped into a mixing tank. The determined amount of PMAP reagent will be added to the mixing tank to form a slurry. The slurry will be pumped using a floated hose. The hose will transfer the slurry to the specified injection points. The slurry will be injected into each point.